So in this session, I am going to talk about HUFFMAN coding. So the purpose of this HUFFMAN coding is to obtain the unique code words. The derived codes is also a prefix code words. So when you say a prefix code, then the no code word is prefixed to any other code word. So such a code is called as prefix code. So HUFFMAN coding algorithm is used to derive the prefix codes for the given discrete numerical source. So generally the source consists of some set of symbols. Say for example, if you take the sources S, that consists of k symbols. Say for example, S0, S1 up to Sk minus 1, then their probabilities will be given. P equal to, say it is P0, P1 up to Pk minus 1. So here the source consists of k symbols and the k probabilities are given. So P0 is the probability occurrence of the first symbol, then P1 is the probability occurrence of S1, and Pk minus 1 is the probability of occurrence of the symbol Sk minus 1. So for a discrete numerical source, when you add these probabilities, say P0 plus P1 plus P2 plus up to Pk minus 1, that will add up to unity. So I can write this as summation k equal to 0 to k minus 1 P suffix k is equal to 1. Now such a source is called as a discrete memoryless source. Then additionally, the occurrence of the symbols must be statistically independent. So when a symbol S0 occurs, then it need not depend upon the other symbol to occur. So it has a statistically independent properties, and by using HUFFMAN coding, we are going to find some unique code words for the given source symbols. So in this session, I am going to talk about the HUFFMAN coding algorithm. So for that, I am going to take a discrete memoryless source. For that codes, for that source, for all the symbols, first we are going to derive the corresponding code words. Then I will compute the average code word length, and then I am going to calculate the corresponding entropy, right? So here I am going to take a source that consists of 4 symbols A, B, C and D with the probabilities A equal to 0.4, B equal to 0.3 and C equal to 0.2 and D equal to 0.1. So the first step in this algorithm is we have to check whether these probabilities add up to unity. So 0.4 plus 0.3 is 0.7, 0.7 plus 0.2 is 0.9, then 0.9 plus 0.1 becomes 1. So this is the first condition the given symbols has to satisfy. Otherwise, the given statistics term to be wrong. You can apply HUFFMAN algorithm only to a discrete memoryless source. So here the first step is we have to arrange the symbols in the decreasing order of probabilities. You have to arrange the symbols in decreasing order of probabilities. So the highest one is the symbol with the probability 0.4. So A is having the highest probability of occurrence. Therefore, the first symbol I am going to take is A with the probability 0.4. Then The second symbol is B. So B is having the probability of 0.3. Then C is having the probability of 0.2. Then D, the symbol D, is having the probability of 0.1. So here you have to see the symbols are arranged in the decreasing order of probabilities. So that is very important. 0.4, 0.3, 0.2, 0.1. Then I have to combine the last two symbols. The last two symbols I can combine, and you can assign 0 for one symbol and 1 for another symbol. So I combine last two symbols and you can assign 0 for first symbol and 1 for the next symbol. Now the total probability here is 0.3. 0.2 plus 0.1 is 0.3. Now again I have to move this symbol in the order. So here I have already 0.4, 0.3. Now I have two options. I can keep this combined symbol with a probability 0.3 either above this 0.3. I can keep above this 0.3 or I can keep below this 0.3. So there are two possibilities, but when you move the symbol as high as possible, then the variance will be less. The variance of the derived code words will be less. Therefore, it is always better to move the combined symbol as high as possible. So here the combined symbol is 0.2 and 0.1. Therefore, I can keep this symbol between 0.4 and 0.3. So you can take this as 0.4. Then I am going to keep this combined symbol here. So this is 0.3. Then I am going to move this symbol here. So this is 0.3. So in the first iteration, I have 4 symbols. Then the second iteration, it is reduced to 3. It is reduced to 3. Then I am going to combine here the total number of symbols is 3. Therefore, I have to continue this procedure until I am left with only 2 symbols. Therefore, here you can combine these two symbols, 0.3 and 0.3. So 0.3, 0.3, 0.3 plus 0.3 is 0.6. Then I can move this combined symbol here. So this is 0.6 and this 0.4 will come here. This 0.4 will come here. So here I have 0.4. Right? Then here I have to assign 0, 1. Here I have to assign 0, 1. Right? So I have 4 symbols A, B, C and D, and the corresponding probabilities are 0.4, 0.3, 0.2 and 0.2. The first step is I have to arrange the symbols in the decreasing order. I have arranged. Then combine last two symbols. So the last two symbols are combined. Then you have to assign 0 for one symbol and 1 for another symbol. Then you have to move the symbol to the next level, and you have to see that the symbols are arranged in decreasing order. So here it is 0.4, 0.3 and 0.3, and you have to keep it in mind, you have to move the combined symbol as high as possible, right? Then you combine last two symbols, 0 and 1 are assigned. Now I have left with only 3 symbols, therefore I am doing this combination. Then you have to move the symbol, 0.3 plus 0.3 becomes 0.6. So 0.6 I have kept here, then 0.4 is here. So you combine the symbols 0 and 1. Now I am left with only 2 symbols. I have only 2 symbols. Therefore, I can stop this procedure. I can stop this iteration, right? So now this algorithm is over. The next step is I have to derive the code words. I have to derive the code words for the symbols. So here I have to trace the symbols from the backwards, right? So or I can trace from here, and you have to move the symbols as I will explain here. So here 0.4 moves here. So here I am not assigning any code words. I am not going to assign 0 or 1. Then this 0.4 goes here. Here I have assigned 1. So now I have to keep this 1 as the code word for A. I have to keep this 1 as the code word for A. Right? Then 0.3 is here. Then it goes here. Now this 1, I have assigned 1 here. I have assigned 1 here. Now you have to take this 1 as the LSB. I have to keep this 1 as the LSB. Right? So this is the one that occurs first, whereas I have to keep that as the LSB symbol. I have to keep that as the LSB symbol. Therefore, then it goes here. So here it is 0.6. Here I have assigned 1, 0. So you can take 0 here. Then the next symbol is C. Here I have assigned 0. So now this 0 is the LSB. 0 is the LSB. Therefore, you can assign 0 here. Assign 0 here. Right? Then it is combined here. It goes here. Here also you assigned 0. Here also you assigned 0. Then it is combined and moves here. So here I have assigned 0. So 0, 0, 0. Then the last one is, the symbol is D. Here I have assigned 1. So 1 will be the LSB. Then it goes here. Here you assigned 0. Then it goes here. 0, 0. Right? So these are all the code words. These are all the code words we have derived. So 1 is the code word for A. 0, 1 is the code word for B. 0, 0, 0 is the code word for C. And 0, 0, 1 is the code word for D. So now we have derived the code words. We have derived the code words for the given set of symbols. Right? So next I have to calculate the coding efficiency. You have to calculate coding efficiency. The coding efficiency is given by the H of S by L bar, where H of S is the entropy of the source and L bar is the average code word length. So here the H of S I can calculate first, then I have to calculate the corresponding L bar. Right? So here I am going to calculate the entropy of the source. I am going to calculate the entropy of the source. So this is the probabilities I have calculated. A, B, C, D. The corresponding probabilities are 0.4, 0.3, 0.2, 0.1. Then for the first symbol, the code word is 0. Second symbol 0, 1. The code word for third symbol C is 0, 0, 0. And for D is 0, 0, 1. So now we have to calculate the entropy. So entropy is given by entropy is given by H of S is equal to minus summation K equal to 0 to K minus 1 Pk into log Pk to the base 2, and the unit is bits per symbol, right? And here one of the important thing is, here this is logarithm to the base 2. So in calculator you will be able to find only logarithm to the base 10. Therefore you must know how to calculate the logarithm to the base 2. So here this is given by, so I want to calculate logarithm to the base 2, pk to the base 2. I can write this as log pk to the base 10, log pk to the base 10 into log 10 to the base 2, log 10 to the base 2. I can write like this. I can write log pk to the base 2 is equal to log pk to the base 10 into log 10 to the base 2. Then I can write this as log pk to the base 10 by, I can take this to the denominator, so that we will be getting log 2 to the base 10. And log 2 to the base 10 is, in the calculator you can see, it will be 0.3010. Then 1 over 0.3010 is, it is 3.32 log pk to the base 10. So here I am explaining how to find the logarithm pk to the base 2. So here when I want to calculate log pk to the base 2, I have to calculate log pk to the base 10 multiplied by 3.32. So if you want to calculate logarithm to the base 2, just you calculate logarithm pk to the base 10. Then the final answer must be multiplied by 3.32. Right? So this one you have to remember. You have to remember this. So log pk to the base 2. So I can write here. You can remember this. To find log pk to the base 2, you have to find log pk to the base 10 and multiply by 3.32. This is important, right? So here then you can take this as k equal to 0 to, so number of symbols, the source alphabet is 1, 2, 3, 4. Therefore summation k equal to 0 to 4 minus 1. 4 minus k equal to 4. Therefore you can take this is 4 minus 1 is 3. So I can write this as pk log pk to the base 2. Then I can write this as minus, can take this k equal to 0, p naught log p naught to the base 2 plus p1 log p1 to the base 2 plus p2 log p2 to the base 2 plus p3 log p3 to the base 2. Right? Then here I am not able to find logarithm. Now to find this log p naught to the base 2, I have to find p naught to the base 10. Then the result must be multiplied by 3.32. Therefore I can take this 3.32 outside, so that I have minus 3.32 into p naught log p naught to the base 10 plus p1 log p1 to the base 10 plus p2 log p2 to the base 10 plus p3 log p3 to the base 10. Right? Then I can take this as, I can substitute the probabilities. So 3.32 into p naught is 0.4. So this is 0.4 log 0.4 to the base 10 plus p1 is 0.3 log 0.3 to the base 10 plus 0.2 log 0.2 to the base 10 plus 0.1 log 0.1 to the base 10. Right? So here this is the equation for entropy. So entropy is the average amount of information gained by observing an event. Observe occurrence of a symbol from the source alphabet. So this is going to be the average amount of information. So it is given by summation, that is minus summation k equal to 0 to k minus 1 pk log pk to the base 2. The unit is bits per symbol. Then the number of symbols k, capital K is the number of symbols. Capital K is the number of symbols in the source alphabet. So number of symbols is 1, 2, 3 and 4. Therefore, I am going to take k equal to 4. So once the k becomes 4, then k minus 1 becomes 3, pk log pk. Then I am expanding this equation. Then I am changing the base, logarithm base from 2 to 10. So I am going to multiply this by 3.32. Then this is the logarithm I have to take. So here this is minus 3.32 into 0.4 and log 0.4 to the base 10. Log 0.4 to the base 10 will be, when you take this logarithm, you will be getting this value is minus 0.3994. So in the calculator you check point, when logarithm to the log of 0.4 is minus 0.3994 plus 0.3 log 0.3. So log 0.3 is minus 0.528 plus 0.2 into 0.2 is minus 0.69. It is minus 0.69 plus so it is 0.1 . So the final one, this is 0.1. So the total value will be, so this is minus 3.32 into minus 0.55576. This is equal to 1.84 bits per symbol. 1.84 bits per symbol. Right? So this is minus 0.1. So this is the entropy of the source. So you can note down the entropy. H of S is equal to 1.84 bits per symbol. 1.84 bits per symbol. So now I have calculated entropy. So next one is the average code word length. The average code word length. So this is L bar. L bar is equal to summation k equal to 0 to k minus 1 pk into lk. Pk into lk. So here pk is, here the unit is bits per symbol and pk is probability of the kth code word. So that we are using continuously, and lk is the length of the kth code word. Lk is the length of the kth code word. Right? So here already I have applied HUFFMAN coding. So the symbols probabilities are 0.4, 0.3, 0.2 and 0.1, and these are all the code words. So for that we can calculate the corresponding length. So here the length of this 1 is 1, and here 0, 1, so length is 2, 0, 0, 0, so length is 3, 0, 0, 1, so the length is 3, right? So here now you can take this as summation k equal to 0 to capital K is 4, 4 minus 1, 3, pk into lk. Then I can expand this as P naught into L naught plus P1 into L1 plus P2 into L2 plus P3 into L3. So now you have to substitute these values. So P naught is the probability of the first symbol. The first symbol is A, the corresponding probability is 0.4 into L naught is corresponding length. The code word is 1, so length is 1. It has only one bit code word, so it is 1 plus 0.3 into its length is 2. Then the third symbol probability is 0.2 into the length is 3 plus the fourth symbol probability is 0.1 into its length is 3. Then I can write this as 0.4 plus 0.6 plus 0.6 plus 0.3. So it is 0.4 plus 0.6 is 0.4 plus 0.6 is 1, 1.6 plus 0.3 is 1.9. So it is 1.9 bits per symbol. Then I can calculate the corresponding the efficiency. So the coding efficiency is given by eta equal to h of s by L bar into 100%. So h of s is the entropy of the source. So it is 1.84 bits per symbol, and the L bar is 1.9 into 100%. So this is equal to 96.84%. 0.84%. So this is the HUFFMAN algorithm. So here the important thing is, first you have to arrange the symbols in the decreasing order of probabilities. Assign 0 for, you have to combine last two symbols. Assign 0 for one symbol and 1 for another symbol, and you can continue this procedure until we are left with only two symbols. Then you have to trace the code words. Then you have to calculate the entropy of the source h of s. Then the average code word length is calculated, and finally you can calculate the coding efficiency. So this will give you the one of the efficient code words. So here the derived codes is a prefix codes. So here prefix code means no code word is prefixed to any other code word. So when you take this one, the one will not come in the prefix. So this is 0, 1. Here you cannot see 0, 1 in the prefix of the code words. So all the prefix code means it is uniquely decodable. Right? Thank you.